All right, so any questions up to here? I'm seeing lots of discussions on Canvas, which is awesome. Keep making use of that. Yes?
Was it supposed to be part of our program to catch the 0 divided by 0 problem?
You should never, so you should definitely handle if there's a 0 in the denominator. And remember, if there's a 0 in the denominator, the number is considered undefined, and then you do totally different things with it for everything. If you add, subtract, multiply, or divide with an undefined, the result is undefined. If you try to convert it to a string, you should return NaN. If you try to convert it to a double, you should return double.NaN. And I think those are the only things you do. If you ask for get denom or get num, just return whatever you've set your denominator and numerator to. That's kind of an edge case. So this question of if it's 0 over 0, it's exactly the same as if it's 1 over 0 or negative 5 over 0. It's simply undefined. So operating with it gives you undefined. String is nan and double is double.nan. Does that cover all the cases?
Yes, I was just talking about a specific case because I was using the code featured in PA1 on the description, and my program tried to initialize a toward the end because 0 over 0 came up back with an exception error.
Okay. Yeah, so you should
dividing by 0.
Yeah, so you're doing something that you shouldn't do in the code then.
I already figured it out.
You already figured it out?
To do with our greatest common denominator.
Oh, okay, right. So yeah, the GCD code will probably throw up if you feed it 0 and 0, or maybe anything in 0. So yeah, that's the other thing we do is simplifying, and if your number is not a number, no need to simplify.
For some reason it doesn't do it when the numerator is not a non-zero, but it only acts when the numerator and denominator are both 0.
Okay. Okay, but you fixed it, right?
Yes.
Okay, awesome. Good deal. Other questions or comments?
What are some common Java phrases or commands you want us to do, or things that we should know about?
So far, it's Java C and Java. That's pretty much it.
If we find funky stuff, like, should we use it or should we try and keep it?
What do you mean funky stuff?
Well, like, you showed us that big list of just built-in Java operations.
Oh, yeah. So let's talk about this. A couple of things. One, there's always going to be classes out there that already exist that do most of what we want to do in these assignments, right? So you definitely don't want to just use those. So GCD, I mentioned in the new assignment, write that yourself, okay, even though you can find implementations of that. If we're working with linked lists in PA2, for example, you need to write your own linked list. We're going to talk about that this week, how to do those. But the other thing I want to sort of catch early is I'm looking at some people's code, and I'm seeing all kinds of things that we haven't talked about and probably won't talk about for a few weeks. Try-catch blocks, the keyword this, exceptions, things like that. These are all valid parts of Java, and they're good things to use, but the fact that we haven't talked about them yet means one of two things is going on. One, you already know how to program in Java, right? In which case that's good. Or two, you're looking at other sources and using things, and the concern there is you may or may not fully understand what you're using. There's lots of ways to take the keyword this and put it in your code and have it still work without knowing what that keyword does. And then it's really easy when I start asking you questions about it on a test to get it wrong because you didn't pay attention when we actually went over it because you've already been using it. So I really want you to, if you find things outside and you're tempted to use them, let's talk about it. Okay, you can ask in class, you can ask on Canvas, you can shoot an email, office hours, whatever, and say, hey, I found this way to use this try-catch block to deal with division by 0. right? And in that case, my response would be, okay, can you find a way to deal with division by 0 without using a try-catch block? Because that works, but it's considered a really kind of sloppy way to do what you should be doing with an if statement. And it can become a crutch. So just kind of be aware of that. If you're finding things outside and you're using things we haven't gone over in here, and it's not stuff that you just already know and understand completely, shoot me a note or ask about it in class, and we'll build from there. A lot of the stuff we'll get to eventually, but I want to make sure that you actually understand it if you're putting it in your code. Does that make sense? Okay. So I posted another test program, PA1 test B.java, which is exactly like PA1 test, but it just has a few extra things here at the end for dealing with positives and negatives and division by 0 more. So there's some extra tests if you want to try to make sure like 1 over minus 5 converts to a string as -1/5 instead of 1/-5, stuff like that. So those are just some of the cases we talked about last week, but there's some test code for it. But you should always be writing your own test code, obviously, and building up from there. All right, is that sign-in sheet done going around? Cool. Thank you. All right. So PA2, which we'll talk about on Friday, is going to involve linked lists. And so we want to talk this week about implementing linked lists in Java. And there's built-in packages for doing this, but we want to roll our own. We want to make sure that we know how to build a class that implements a linked list. And it's a fair amount cleaner than how it appears in C. So what you learned about lists in C will apply here, but the implementation will be a lot cleaner. And to kind of warm up for that, I want to implement a different class today. I want to implement a stack class. And let's see how that looks. Quick note, there's going to be an observer coming in on Friday and another one on next Wednesday to watch me teach. So you'll see Izad sitting in here Wednesday afternoon, and someone else on Friday. So that's why there's people you don't recognize sitting in class. So just a heads up. All right. So let's build a stack class, and I'm going to have you do this in groups. There's 17 people here. So groups of 3 should work. So go ahead and find 2 friends and find a spot on a board, and let's make groups of 3, a couple of groups with 4, and we'll develop this class together.
Groups of 3 to 4?
Yeah.
Okay.
All right, so do we have 3 groups back there? Your 3 groups, okay, and a group there, and a group there, and you're going to be a group up here? Okay, cool. All right, so let's just start back here, and we'll go around, and I'm going to ask questions, and if you can answer these, fine, and if not, you can ask for help from other groups, and we'll all kind of chime in and do this together, okay? So first thing, we're going to make a class called stack. Okay, so what's the first thing you're going to write in your stack.java file?
Class stack.
All right, go ahead and put that up. And I'm going to copy what we're developing. Actually, I'm going to go ahead and put this in code. All right, so we got class stack. That's the beginning of our class. So if we're implementing a stack, let's implement this with an array. Let's not worry about linked lists for now. We'll just do a simple array-based implementation. So what are the two things we need to implement a stack with an array?
We need a set value for the array.
Okay. What else do we need?
Do you need to give it something that points to the top of that?
Yes, so that's called a stack pointer. So we need a stack pointer, and then we need an array. So this is going to be a stack of integers. So an array of integers and a stack pointer. Okay, so can you declare an integer SP to be our stack pointer? All right, so there's our stack pointer. And I'm going to, remember when we talked about stacks before, there's at least 4 different ways we can interpret the stack pointer. It can be the address of the next thing to push, the next thing to pop, it can be one less than, and so on and so forth. So I'm just going to make a decision here and say SP is the address or the index for the next push.
We don't make a stack pointer a star SP, do we?
No, there's no stars in Java for one thing, but also this is just going to be an array of integers, and SP is going to be an index in that array. So this is a 121 style stack. All right, next group. Take a shot at declaring an array of integers named stack. And we've seen an array of strings when we declare our main method. Do you remember what the string array looks like?
String.
So for strings, we do something like main string bracket bracket arg. So that says I want a string. This says I want an array of strings. So what would you guess for an array of integers? Yeah, so int bracket bracket says I want an array of integers. And let's just call it stack for the actual array name. And so stack itself is declared to be an array of integers, but it's not actually pointing to anything yet. In the same way that if we say integer star stack in C, and we try to use stack bracket 0, we get a seg fault. Because if you say integer star stack in C, you have to eventually say stack equals malloc some amount of space, right? So we're going to have to do the equivalent of malloc in Java, which is the new keyword. So at some point we'll have to say stack equals new int bracket and then say how many ints we want. So we'll come to that in a moment. But this is basically all we need variable-wise, just the stack pointer and the stack itself. Okay, now if I use this from a main program, let me start a main program. This is how I want to actually create a stack in my main. I'm going to say stack s equals new stack. And that's going to give me this object s, which is a stack. It's a stack pointer, it's an array of values, and it's also code for pushing and popping and so on and so forth. So I'm going to construct it like that, which means we need a constructor. So can you take a shot at making a constructor for a stack, or starting a constructor for this class? Okay, cool. So it looks like a function declaration. The one weird thing about constructors is you don't specify a return type. Okay, but we are going to say public because we want to make sure that it's public. And while we're at it, let's go ahead and make these stack and stack pointer private. Provat. Okay, by making them private, we're saying that this main program, for example, can't say s.sp equals something, or show me the value of s.sp. Main has no access to sp, it has no access to the stack array. So everything it wants to do with the stack is going to have to do through methods defined in this class. Okay, that's a feature, that's a goal. Okay, so here's our constructor, so public stack. All right, we got to do two things to create a new stack. Any idea what one of them is?
We need to define the length.
Sort of. That's okay.
Is that the mallet thing?
Yeah, so we need to create space for the stack itself. So, want to take a shot at it?
Stack equal new.
Wait, what are we making?
We're making an array of ints.
So new int.
So new int. And then we just put in brackets how big we want it to be. So let's just default to an array of 10 integers. We'll talk more about arrays formally later. So stack equals new int bracket 10. All right, and then what's the other thing we have to do to initialize a stack? Set the stack pointer. Okay, and this is where the convention comes in. If we're a PIC processor, we set it to one thing. If we're x86, we set it to something else. So the convention I'm adopting is SP is the index for the next push. So the picture in mind is something like that. Here's stack, and it's an array of 10 things. And the first time we push, we're going to save right here in element 0. The second time we push, we're going to save here. So the stack's going to do what we call grow in that direction. The last thing we push before the stack fills up will be down here. And we're saying SP is going to tell us where the next thing should be pushed. So since the first thing we want to push is here, we're going to initialize SP to 0. And when we push, we're going to increment it after we push. So SP equals 0, this is where we save the next push. So there's a constructor. So let's see if this works. So I can compile main, that works fine. I can run main, that works fine. Didn't do anything, but that's okay. All right, so what else do we want to do with a stack besides construct it? What are the operations we do with stacks?
Push and pop.
Push and pop. Okay, so let's make a push method. So if S is our stack, we want to be able to say something like S dot, well, I'll just put it here. So you want to be able to do something like push some values. All right, so back around to the beginning. So can you start a push function, push method? So it's going to be public.
Are we returning a stack?
We're not returning a stack, right? We're actually using a stack to access this method. So for now, let's just return void, which means we don't return anything. All right, so the method is called push, and it takes an argument, which is integer num. Perfect. All right, cool. So next group. If we're going to push a number, where do we store that number? Where do we save it in our stack? At SP. Okay, can you make a statement that saves num at element SP in the stack? Perfect. So stack bracket SP equals num. That takes your number, it saves it in your stack. All right, next group. What do we do after we save? Increment SP. SP would work as well. So when we said stack SP equals num, we could have said stack bracket SP plus plus, post increment, right? So that would save it and then increment, or we can do it in 2 steps. And that's pretty much all we need for a push. So, question, how can we get into trouble with this? How can we get into trouble with push?
If something's already in the index, or we reached the end of the index.
Or if it's full.
Yeah, if you reach the end of it, right? Our array will only hold 10 elements, and we're just saying save it at element SP and increment SP. If we call this more than 10 times, SP is going to be 10. This is going to give us an error saying the array is out of bounds. So we really want to check to see if the push is going to blow up the stack or not. So I'm going to make 2 suggestions. One, I'm going to change this to return a Boolean, a true or a false. And I'm going to say this returns true if it's successful or false if the stack was full. So before we do what was already written, we're going to say, is the stack full? So next group, how can we tell if the stack is full? If SP equals 10. So if SP equals 10, we'll return true, saying the stack is, we'll return false, saying the stack is full, and we won't do anything else. Otherwise, we'll go ahead, we'll save our number in the stack, we'll increment the stack pointer, and then we'll return true. Which shows that we did push. Okay. Does that look good? All right. So next group, what about a pop? So let me make some sample code. So we're going to push 4 times, and then we want to pop something. So what does a pop look like?
Publican pop.
Okay, good. Public int pop doesn't need any arguments. And so how do we pop?
Should we do a Boolean pop?
We're going to have to think about that because we want to know if the stack was empty when we tried to pop. But mostly we want to return the value that we popped off. So I'm going to make this an integer, and we're going to think about the Boolean in a minute too. But supposing that nothing goes wrong, how would we pop from the stack?
We take stack pointer
Or would it be
and return the value.
stack SP?
So it would be stack SP. So let's look at our picture. So suppose we push a 10.
Oh, it would be SP. Would it be SP minus 1?
So this would be a 10, SP would be equal to 1. So when we want to pop, we want to return SP minus 1, whatever's stored at that index. And when we're done, we want the stack pointer to be decremented. So that next time we don't return the same thing, but we return the previous thing. So 2 steps to pop: decrement the stack pointer and then return the value.
Right.
Right?
We don't need to save it to a different other variable.
No, we can just return it.
I'll return the number first and then decrement, right?
Well, no, because
Yeah, except we can't return and then do something, because when we return, we're gone. So that's just kind of.
by decrementing first, it makes it SP minus 1 too. So we don't have to worry about that.
All right, so decrement the stack pointer and then return. So the push is saving and incrementing. It's a post increment. The pop is decrementing and then returning, so it's a pre-decrement. And those need to sort of be in harmony with each other. All right, so here's the question though. What happens if the stack is empty and we call pop?
It holds nothing anyways.
What is SP when the stack is empty?
-1.
When the stack's empty, it's 0, so if we decrement it, SP is going to be -1, and we're going to ask for element -1 from the stack, and that's going to give us an index out of bounds exception. So we really don't want to do this if the stack pointer is already 0. And ideally, what we'd like to do is somehow tell the user that they tried to pop something they shouldn't have.
Could we make another function that's a Boolean and then throw this pop inside of that?
So, yeah, but then we don't have a way to get back the integer.
Should we make a flag or something?
So we could pass an argument as a flag and get it back, but since we're just doing this as kind of an exercise, let's just be sloppy programmers, okay? And let's say if the stack is already empty and they try to pop, let's just return.
Return null?
We could return null, but let's just return 0. And it's a goofy thing to do, but we're going to tell the user very clearly, never call pop if the stack is empty. If you do, bad things will happen. Okay, so danger, never call pop if the stack is empty. And so that just has to be specified to the user. But if they happen to call it when it's empty, well, let's just let it blow up. That'll be fun. This is how we teach the user how to read documentation. All right, so how can we help the user avoid calling pop when the stack is empty?
We need to know if it's equal to 0.
Okay, so we need to know if the stack pointer is equal to 0. In other words, the user needs a way to know if the stack is empty so they can know whether or not they should call pop. So let's make an isEmpty function. So check this before calling pop. All right, so what could this function look like? We want to return true if the stack's empty, false if it's not.
It's a simple if statement of 0.
Okay, so what's the if statement look like?
If stack pointer is equal to 0,
Mm-hmm.
return true. And return false.
Otherwise, return false.
Well, now all we need is an if else to make sure our pop doesn't break.
Yeah. So, a couple of things here, right? We don't need an else on the return false, because if stack pointer equals 0 and it returns true, it's not going to get down to that next statement. So we're okay just writing the next statement as return false. Could we do this as one line of code?
Yes.
How do we do that?
It's that funky algorithm required using a question mark.
We could do it with a question mark.
Could we do return and then if, all that stuff?
Kind of. Anyone know another way to do this?
Is it return SP equals 0, question mark, true, colon, false?
Yeah, that was Connor's suggestion. There's a slightly simpler way.
Is it just return SP equals 0?
There we go.
Just return SP equals 0. When you say SP equals 0, that evaluates to a Boolean. And it'll be true if SP is 0 and false otherwise. So we can just return that. You don't have to, right? 2 if statements, 1 if statement, an interrogation, ternary operator, those are all perfectly clear. But if you're like running out of characters, you can save a few like that. All right, perfect. So there's our isEmpty function. So let's play with this. So we've pushed a bunch of things. So let's look at the stack. So I'm going to say, well, S is not empty. Well, not S is empty. So while there is stuff on the stack, and let's just call s.pop and print out what it gave us.
Should we have the isEmpty in the pop statement?
Pop doesn't take an argument.
Isn't pop a function though?
Pop is a function. Oh, we should have parentheses on it, yes. Oh, you mean inside the code of pop?
Yeah.
So if we want to be kinder and gentler to the user, we could put something like we could do something like that. If is empty, return some weird number. Which is kind of kludgy because that could be the number that they actually pushed and they might think they actually popped that off. But if we don't want to get that exception by our array going out of bounds, right, we could do this. And we can use the isEmpty function. It's just a function, right? Even though it's part of this class, we can say if isEmpty, and it means, you know, if this object that we're using to run this is empty. So we're just going to loop as long as the stack's not empty. We're going to call pop, print it out, and when we're done, we'll say goodbye. So we're printing the values, we're pushing the values 12, 200, negative 25, and 100. So when we pop, we should pop off the 100, minus 25, 212, and then the stack should be empty. So let's try this. So pop returned 100, minus 25, 212, and then it found it was empty and it said goodbye. So good job, you wrote a stack class. Awesome stuff.
That is pretty clean.
And yeah, the way we use this is so much more kind of self-contained from what it was in C. In C, we had to say push stack comma number, or variable equals pop parentheses stack, or initialize stack, right? Here we construct the stack the same way we construct everything with the new keyword. And once we have that stack object, S in this case, we can say s.push, s.pop, s.isEmpty.
We're not going to cover how we put numbers into the program yet, are we?
Like from standard in?
Yes.
Pretty soon. But we haven't yet, but we'll talk about the scanner class. That's the easiest way to read things in. All right, so what group did we leave off with you? I think so. Okay, so here's an idea. Let's make an alternate constructor. Which lets you specify how large of a stack you want. So right now when we say stack S equals new stack paren, we get a stack that can hold 10 things. Suppose we know we want a stack that can hold 100 things. I'd like to be able to say something like this. Stack S equals new stack, and say I want 100 elements in my stack. So I want a different constructor, still have the default one, but I want a new version of this. So what has to change in here?
On the stack parentheses, you put in an argument exception, like int number.
Okay, so we'll pass an integer called number that can hold number elements.
And then change the 10 to number.
And then just change the 10 to a number. Perfect. There's our new constructor.
Change that.
So yeah, so next group. We have a 10 hardwired down here in our push. And with this line of code, once we get to 10 elements, it's going to think our stack is full. So logically, what should we have there instead of a 10?
Number.
Yeah, number or something that tells us how big the stack is. So do you happen to remember how to tell the size of an array?
Size of?
Nope.
Length?
Length. And length is a field, so it's not parentheses, parentheses. For a string, length is a method, so it gets parentheses. But with an array, if we want to know how many things are in the array, it's just array name dot length. So if we've used all the space, then the stack is full. So we could check the return value from push, and if it ever comes back false, we know the stack's filled up. Make sense? All right, cool, good work. All right, you can go ahead and sit back down. Erase your boards if you can, yeah.
Maybe borrow that eraser.
All right, so that's over on the download area. All right. Let's see, did we already talk about how to reduce? Did we go over the details of Euclid's algorithm? I promised to do that, so let's look at some details of Euclid's algorithm. So, we want to find the greatest common divisor of 210 and 63. So the way we do this, we write 210 equals 3 times 63, which is 189 plus 21. And then we carry these over. And we say 63 equals 3 times 21 plus 0. And once we have a 0, right, this thing is our GCD. So in general, if you want to find the GCD of A and B, right, you write A equals something times B plus something. Well, this something over here is just the remainder when A is divided by B. So we can do something like remainder equals A modulo B. And then when we do this business, when we push these things over here, what are we doing? We're saying A equals B, B equals remainder, and then we go back and we do this again. And we keep doing this loop, right, and we stop when R equals 0, and when R equals 0, B is the greatest common divisor. So that's Euclid's algorithm from CSE 215. We kind of wave our hands but never really prove that Euclid's algorithm works in 215, but we can do that pretty easily. And seeing why it works gives us a really efficient way to implement this. So why does this work? A and B, we're looking for the greatest common factor, right? So suppose that F equals the greatest common divisor of A and B. Okay, in addition to being the greatest common divisor, F is a common divisor, which means F divides A and F divides B. Well, when we do this step up here and we say A equals X times B plus some remainder, that remainder is A minus X times B. Well, go back to some of the things we proved about divisibility. If F divides A, if F divides B, F divides X times B. Right, so F divides B means that F divides X times B. And we also know that F divides A, and therefore F divides the difference of this thing and that thing. Right, A is a multiple of F, XB is a multiple of F, their difference is a multiple of F. And A minus XB is a remainder, so F divides the remainder. So this means the greatest common divisor of A and B. This means any common divisor of A and B is also a divisor of this remainder. So here we were looking for a divisor of 210 and 63. Any such divisor is also a divisor of 63 and 21. So if we find the largest thing that divides both of these, it's going to be the largest thing that divides both of these. Right? Because it's got to divide 63. And it's going to divide 210 because both of these are multiple. So really what we're doing with Euclid's algorithm is we find A equals something times B plus some remainder. We find the greatest common divisor of B and R. And that is the GCD of A and B. So you can do this recursively. You can find the remainder when A is divided by B. And if that is not 0, find the GCD of B comma R and just return that. If this is 0, then B is the GCD. So it's a few lines if you do it recursively, and this is tail recursion. It's recursion as the last statement of your function, and when you have tail recursion, you can replace it with a loop. So if you do this as an iterative procedure, you're just unrolling that tail recursion. But either way is fine. Okay, so it may work if your numbers are negative, but it makes my head hurt to think about it. So I usually try to make sure my numbers are positive, and if they're actually negative, just divide the original numbers by the GCD. But somebody earlier said they totally ignored the question of positive, negative, and it all seems to work. So you can play with that if you like, or just find the GCD of the absolute value of A and B, and then divide A and B by that. So that's a way to reduce. All right, any questions on that? Cool. So so we will start moving towards talking about lists tomorrow. And if you have questions on PA1, of course, bring those in and we'll talk about them. Otherwise, we'll start building up some more data structures tomorrow.
Maybe.